national and international journals and conferences. His work spans areas such as wearable electronics, renewable energy systems, and biomedical engineering. Some of his notable research achievements include development of wearable electronics for defense and biomedical applications, innovations in renewable energy system, including IoT-based smart meters for smart city applications, advancements in power quality improvement in grid-connected systems. He has authored 32 books published by leading international publishers like Springer, Elsevier, and CRC Press, and contributed 36 book chapters. These works have cemented his reputation as a thought leader in his field. His inventive spirit is evident in the development of 27 products, 23 of which has been successfully transferred to industries. His projects are often funded by prestigious organizations, including the Department of Science and Technology, Defense Research and Development Organization, and the Indian Council of Medical Research. He has managed over 28 government-funded projects worth 12.5 crores, focusing on the areas of national importance. He has guided 12 PhD scholars and is currently supervising 9 doctoral candidates. He has also mentored over 100 graduate and postgraduate projects, reflecting his commitment to nurture future innovators. Dr. Kumar has organized more than 112 conferences, workshops, and seminars fostering knowledge exchange and collaboration among academia, industry, and policy makers. His contributions have earned him numerous awards, including the Professor K. Arumugam National Award for Innovative Engineering Research, Outstanding Engineer Award from the Institution of Engineers, India, Young Engineer Award for his pioneering work in electrical engineering, recognition for his academic contribution with the PhD Teacher of the Year Award. His international recognition includes being selected as the Bhavan Fellowship by the Indo-US Science and Technology Forum, allowing him to conduct postdoctoral research at San Diego State University, USA. Adding crown to his professional affiliations include Chairman of Indian Association of Energy Management Professionals, Coimbatore Chapter, Senior Member of IEEE, Fellow Member of the Institution of Engineers, the Institution of Engineering and Technology UK, and the Institution of Electronics and Telecommunication Engineers. Midst of your busy schedule, we are very happy to have you with us, sir. We once again welcome you. Welcome, sir.
Yes, thank you, ma'am. Thank you very much for the introduction and the invitation you have done for this ATAL FTP. And what is my time frame, ma'am?
So from 6 to 7:30.
1.5 hours.
Yes, sir.
That's all.
Yes, sir.
Okay, fine. Can I share the screen now?
Yes, sure, sir.
Is my screen visible? Hello?
Yes, sir.
Is my screen visible?
Yes, sir. It's visible.
Okay. Excuse me. So the participants are mostly from electrical and computer science domain, or what, ma'am?
A majority of the participants are from electrical domain, sir.
Okay, fine. Okay, so my topic would be on predictive analytic, as well as I'll be touching upon the importance of data analytics, basically. And I'll touch upon some points related to blockchain as well. Because before going in depth of blockchain or giving an introduction about blockchain, we need to know about the importance of smart grid and how smart grid can be an advanced topic to everyone by implementing the concept of predictive analytics. That is the main objective. Is that okay, ma'am?
Yes, sir.
Okay, fine. As you all know, we are in the era of fourth industrial revolution. Means like each and every data, it has to be stored in a cloud. We call them as a cyber physical system. In general, it can be called as a cyber physical system. Cyber physical system in the sense system, any system consists of an input, process, and an output. And cyber physical system in the sense the inputs, the process, and the output data has to be stored in a cloud. And with that data, we need to monitor the health of a particular system. Again, the system includes the input, process, and the output. And the purpose of this is two things. One is for immediate decision making. And if at all, if there is any fault occurs in a machine, that can be predicted by the data. So here there are two important points. One, to make a system a smart system. Second, and I can make the system smart by collecting a data and defining a particular algorithm so that the machine can learn by itself. The system can learn by itself. Learning a particular system by itself is the first task. Apart from learning, it has to predict what will happen to the system on its own. So to know what has to happen and what to happen, we need a proper data. So the data can be collected by different sensors. And the data has to be read by an algorithm, and the algorithm will tell the health of the machine. Similarly, it can predict when the machine will stop. I'm just giving a generalized idea of what do you mean by cyber physical system and how predictive analytics will take a major role in it. The purpose of a predictive analytic is to identify the fault, like when the machine will stop, when the machine has to be monitored for the periodic maintenance or the predictive maintenance, etc. So that can be done with the help of this data analytics in a smart grid system. I'm going to talk mostly on smart grid system. So there are basically three types of maintenance. Before you go in depth, you need to understand the basics of maintenance. One is called as run to failure, second one is preventive, and third one is predictive. And for the people who are doing PhD and the people who are going to register for PhD, this presentation could be most useful because I'm going to touch upon some key points wherein which you can pursue your research. For example, in the case of a run to failure, it is a conventional maintenance strategy. Like when the machine stops, immediately how fast action can be taken so that the continuous process will go on without any stoppage. So how fast you are reacting, that is called as run to failure. So it will not have any gimmick technique. It will be having a simple process in the production. The production in the sense, even in the case of a smart grid system or in the case of a power system, if at all, if there is any fault, that fault has to be identified and how fast I'm rectifying that fault. That is called as run to failure. Once the failure happens, we can go for a maintenance activity. That is called as run to failure. And the second point is a planned maintenance. For example, in your nearby substation and all, you will be receiving a message stating that on the so and so date, your area will not get a power. There will be a power shutdown in your area for maintenance activity. That maintenance activity is a routine maintenance. Being an electrical engineer, let us say we have a distribution transformer. In the distribution transformer, regular maintenance activity could be just checking the resistance level of a winding, checking the earth resistance, checking the oil level, oil temperature, whether the noise is coming or not, whether the APFC box is working properly or not, and whether the breather is in the good condition, whether the earth pit consists of a charcoal with proper water. So these are all some of the checkpoints we have to check when the planned maintenance or a planned scheduled maintenance. So the first one, run to failure, the person will go and attend the failure once the mistake, once the fault happens. Second one is preventive maintenance, is something like it's a planned one, monthly once, weekly once, quarterly once, we will be doing the maintenance activity. These two things are regular, we are not bothering much about that. And the third important one is where in which we may need to concentrate. There we have lot of scope for the researcher to do multiple research on this particular topic. That is called as a predictive maintenance. It is nothing but a continuous monitoring of a system. Like if you have a power line coming from the substation to your house or coming from the substation to your industry, let us take a HT line. In the HT line, let us say there is a voltage sag or swell. The predominant problem occurs in a system is voltage sag or swell. You can do a complete PhD work on this particular topic, how to mitigate a sag, how to mitigate a swell. The sag and swell varies depending upon the application. The voltage range varies depending upon the application. So if at all, if there is any voltage sag or swell, if a machine can predict when it will happen, based on that, I can operate the entire system or a process. Then that system or that maintenance activity, we call it as a predictive maintenance. So for that, what we need to do, we need to make the machine to learn by itself. That is called as machine learning technique. Sorry, there are a number of machine learning techniques are available in the market. And if I say number of machine learning techniques available, it means that the data are available in plenty. With that data, how fast, how accurate I am predicting the fault. That is called as machine learning technique. Because people can give multiple algorithm, but how fast that algorithm will predict, how accurate that algorithm will predict matters. So a researcher should know what type of data to be acquired to predict a particular fault. For example, you have a lot of power quality indices like voltage sag, voltage swell, intraharmonics, momentary, oscillatory, supraharmonics. Like that, there are a lot of power quality indices. You can address any one of the power quality indices to predict a fault. Similarly, to predict the activity, you predict a log or you predict a report. Or otherwise, you can concentrate on the power factor value alone. Or otherwise, you can concentrate on the voltage dips. So based on that, you can collect the data. After collecting the data, how you are predicting for the future. So this is the technique what we need to do in the case of predictive maintenance. So predictive analytics is a subject on its own. See, there is a separate course nowadays, artificial intelligence and data science, or artificial intelligence and machine learning. So this will tell you the importance of machine learning in our life. In our day-to-day life, we are using machine learning everywhere, right? From mobile to the reels, to the shorts, to the Snapchat streak, we are using machine learning concept. So the same technique can be utilized in the power system or in the grid. So how we have to do it? That can be done with the help of a simple MATLAB. So in this presentation, I'm going to tell you what do you mean by predictive analytics and what do you mean by predictive modeling. And to proceed further, what are the data is required for analysis and what do you want to do for modeling a system? So that is the first objective. Second objective, with the help of MATLAB, how can you do this process of predictive analytics and predictive modeling? And third objective, I have done a few researches in the case of smart grid, in the case of a power system, in the case of a renewable energy system, etc. So those points and those case studies will be shown to you as an example, and those things you can implement on your research, or you can use it in your institution for further process. For example, this slide shows you what is the definition for a predictive analytics. Analytics, for example, you have Microsoft Excel, right? You have huge number of data. To give the data in a readable format, you are using Microsoft Excel. That is a very simple concept. But I'm using the data, the same data, Instead of giving it to a Microsoft Excel, I'm giving that data to a particular algorithm. Let us not worry about the technique of the algorithm and how to develop an algorithm. I'm giving that that data to a particular algorithm. That algorithm will tell you when there will be a high voltage or when there will be a dip in the voltage. So that is nothing but predictive analytics. I hope you people will understand. From node A to node B, node A could be the receiver, node B could be the sender. From node A to node B, before it comes to the receiver, what are all the checkpoints? What are all the possibility of occurrence of faults and how the voltage will dip? Those data has to be included and it has to be given as a data points to the algorithm. The algorithm in turn will do what? It will tell you at so and so point between A and B, there might be a dip at particular day, time with timestamp, and it can alert the user stating that on so and so date there will be a dip, you should be alert. Then it can be called as predictive analytics. And to do the predictive analytics, we need to model it first. What do you mean by modeling? I said there is a point between A, I mean there is a system between A and B, transmitter, receiver. Transmitter is nothing but a generating station, receiver is nothing but the consumer point. Generation, transmission, and utilization and consumption. The entire GTD, generation is the generating point. Transmission, I'm transmitting it via overhead towers or underground cables, and receiving it with the help of distribution transformer, and utilizing it to the consumer point by different applications or appliances. So the entire thing I have to model using a predictive model. And that model consists of different systems that I call it as a cyber physical system. And in each and every point, I need to collect the data. The data could be what? Anything. For example, it can be a current, it can be a voltage, it can be a load line, it can be a power factor, it can be a load profile of the system. So there are numerous data. So these data has to be given to the model, and that with that data, your model can be analyzed with the given data. And that can be done with the help of, hello? Hello? Madam, am I audible?
Sir, you're audible,
It's
sir.
it's audible, sir.
You're audible, sir.
No, someone has asked a question, I think. Is there a question or a disturbance? Hello?
The disturbance.
Madam?
Sir, I think it's a disturbance.
Sir, it's
Okay, if at all, if there is any question from the audience, they can able to ask or they will chat it.
I will put it in the chat box, sir.
Is it not, it's not given to the participants to speak?
We can enable it, sir. We will enable it. In case if there is a need, like
If there is any doubt, let them be open and they can ask doubts.
okay, sir. We'll do the setting. We'll set it, sir.
Okay. If they want, if at all, if any doubt in the corresponding slide, they can open and they can ask, then I can move on to the next slide.
Okay, sir. Okay.
So I was talking about modeling a system and analyzing a system. That can be done with the help of a toolbox. I can suggest MATLAB, and there are multiple toolbox available. Since we are all electrical engineer, MATLAB is known for everyone. There is a toolbox exclusively available in MATLAB. And that toolbox will tell you the process of predictive analytics. And to that toolbox, we have to give data. How can I give the data? I can do the data. I can give the data by means of data mining. Mining means, you know, that the general terminology. I need to mine the data, means I need to get the data. So maximum the data, accurate will be the prediction. For example, with the help of 100 data, I no need a predictive analytics. I can use that with the help of a simple Excel sheet. So maximum the data, accurate will be the prediction. If and only if I have maximum number of data, I need to go for predictive analytic technique. So before going for predictive analytics, we need to know what do you mean by data mining. So for an electrical engineer, they need to know what is data mining. They need to know a little bit of Python. They need to know a little bit of MATLAB. Then you can complete an entire PhD. So this is how a predictive analytic process goes. First data, then from the data we have to analyze it, and in the analysis part we will be informing the user what is going to happen, what will happen, and what is happening. And the result could be a complete prediction of the entire system. So here the tough part is the data, and the second toughest part is how we are giving the data to the model. Right from the, since I have talked about a smart grid system, right from the generation to the receiver point, I need to model, because the system is the one which is defining the entire process. So you need to define a system properly, and to that system you have to give the data. So this is the complete flow analysis of a predictive analytics. So this is the setup. First, create the model, test the model whether the model is right or not, validate it, evaluate it. So defining a model itself is a very big task. If the model is defined properly and if you give a proper input, the prediction will be perfect. And features in predictive modeling could be data analysis and manipulation, visualization, statistics, and hypothesis testing. And how the model, this is how a model works, and this can be taken as an input for MATLAB. Define a project, data collection, data analysis, statistics, and with the statistics, modeling will happen, and finally deployment. In this block diagram, the statistics block diagram plays a major role. In that, statistics is nothing but the algorithm what you are going to define. That algorithm can be anything. It can be RNN, it can be CNN, it can be LSTM. There are a lot of algorithms available in the market, and coding is not a very tough task nowadays. Even a ChatGPT can code, but how a human brilliance can involve which program, which code I have to use it for a particular application. There comes the difference between human being and the ChatGPT. So the coder's value is very simple. The programmer's work is very simple. But which program I have to choose for which application, that is very, very important. How the model will work? It can work from the data given by the customer. And our role is predictive analytics with the data mining. And finally, we'll be having a predictive model. Why predictive modeling? Predictive modeling is used in multiple applications. I have given few lists. For example, CRM. CRM means customer relationship management. The chance a prospect will respond to an ad. Mail recipients likely to buy. When a customer is likely to churn. If a person is likely to get sick. Portfolio or predictive product prediction. Risk management and pricing. See, you may think that the points listed out here are not relevant to you people. But what I'm trying to convey from this particular slide is, without predictive analytics, no market will work. The market, I mean the electricity market as well. Why electricity market? Electricity is a commercial commodity. You people need to understand. Because of that, the blockchain comes into the picture. Electricity is a commercial commodity. We cannot buy it at free of cost. It is a commercial value. It has a commercial, it's like a mobile phone. It has its own commercial value. And how well we are utilizing it. That can be done with the help of predictive modeling analysis. So as I told you, there are numerous predictive models available. Some of the predictive models I have given. I told you in the block diagram, statistics are very, very important. That statistics can be carried out using this some of the predictive model. Linear regression, logistic regression, regression with regularization, neural network. I prefer SVM, support vector machines, a naive-based model, and nearest neighbor classification. I prefer these three: support SVM, naive-based model, and K nearest neighbor classification. And of course, decision tree, ensembles of tree, and gradient boosting. If you feel some of the terminologies are strange, better learn. It is very easy to understand. These are all nothing but simple operations research. It's nothing but statistics. Okay, many of you would have read the statistics and operation research in your UG itself. But here we are using it and implementing in our engineering applications. So some of the applications of predictive modeling already discussed. This I can skip, I believe. Predictive model in telecom industry, these things I can skip and I can directly go on to the predictive analytics software. So these are all the software which is available at free of cost for demo purpose. For example, I think MATLAB, almost all of them have used it and all of them are having MATLAB. My preference is MATLAB. Apart from that, we have R, SAS Analytics, Statistica, IBM Predictive Analytics, and Minitab. Okay, what is PDM? As I told you, predictive maintenance can be done with the help of different statistical approaches, artificial intelligence approaches, model-based approaches. For those people who are doing PhD, my one of the suggestion is you take one problem and with that problem, define an algorithm with the different type of predictive models. You start with LR. I have given some 15 algorithms, 15 model. You start with some 5 model, compare and finalize which is having the best accuracy. And
Mani sir, kindly mute them.
Okay.
Sir, you can continue, sir.
Yeah, please. I was talking about the process of doing a research with the help of predictive model. You take one problem statement, implement that problem statement with a different predictive model, and out of that 5 predictive model, you select one predictive model, implement that in a hardware, and finalize which is the best. This is one of the easiest way of completing a PhD. And the data are available readily. If you want a data related to power system or a transmission system or a distribution system, you can directly go and approach Stanzetco. They can give you at free of cost for the educational institution. Only thing is you need to submit a letter. Or otherwise, if you want any data related to distribution, you can go to any of the RLDC. Okay, you can go to any of the RLDC, submit a letter, they can give the data at free of cost. Or otherwise, you can go to CPRA, they can give the data. I don't know whether they are charging it or not, but the data are available with them. And with that data, because data mining is the toughest one. And if you don't want to do a hardware project, get the data, because collecting a data, it requires a lot of time. Millions of data are required. So millions of data manually as an educational, from the educational institution, it is not possible to define or develop. So get the real-time data. Or otherwise, you may need to develop a simulator. Developing a simulator is also another easy task that can be done with the help of a MATLAB. So that is also that can be also be considered as one of the work. Developing a simulator with the help of a MATLAB for mining the data. After getting the data, implement any of this software. I mean, implement any of the model what I have shown earlier with the help of the software and finalize which is required for predictive maintenance. And that can be done with the 3 different approaches. One is statistical approach, second one AI approach, third one model-based approach. Statistical approach requires mathematical background, like some of them may need a hypothesis, some of them may need tests like t-test, chi-test, etc. Or otherwise, we can go for artificial intelligence approach, or otherwise model-based approach. It is a mechanical model. And these are all some of the most recent papers for predictive maintenance. I prefer you can read any of the paper for understanding the basic concepts of predictive maintenance. Fine. So let us define one by one. Artificial intelligence. So artificial intelligence is a broad perspective. Actually, artificial intelligence is something like if you want to mimic human being, you may need to go for artificial intelligence. And the subset of artificial intelligence is machine learning. If you want the machine to learn by itself, then you can go for machine learning. Another subset of machine learning is deep learning. if you want the machine to predict what will happen in future, then I need deep learning. If I want the machine to be proactive, then I can go for deep learning. So artificial intelligence, machine learning, and deep learning. So these are all the three important concepts required. Like artificial intelligence, any technique that enable computers to mimic human being, and machine learning, it is a subset of artificial intelligence, and deep learning, it is a subfield of machine learning. So I prefer deep learning concepts for predictive analytics. So even though artificial intelligence has a lot of advantages, it has few disadvantages. So let us see that. ANN are intelligent computational technique, mainly inspired by biological neurons. I think many of you know about these basics, and these are all connected by different communication channels. And ANN are mostly used machine learning algorithm. Okay, and they have been used for many applications for prediction as well. And disadvantages are reach conclusion that deny the rules and theories established by the applications. Because in ANN we may use membership functions, and if the particular results are not true, immediately it will give the results or it may deny the output. So that is one. It will not think much. It will go as per the program. That is one of the disadvantage. So these are all the essential learning process to develop a predictive model. As I told you, you can get the data from Tangentco or RLDC or CPRA or POSACO website, from anywhere, and that what you get is a raw data, and it is a unstructured data. What you need to do is, like, you need to structure the data, and structured data can be done with the help of extracting the features of the data. That is called as the feature extraction. Extracting the feature in the sense, you may be given a voltage range from in a day. If it is a single phase voltage, let us say 230 voltage AC, in a day from morning 6 a.m. to 6 p.m., let us say, example, 6 a.m. to 6 p.m., you are checking the voltage variation minute by minute or second by second. So each minute by minute, what will be the variation? What is the range of voltage variation? During the off-peak time, the voltage may go up to 280 voltage, sometimes 300 voltage, example. During the peak time, the voltage may dip to 160 voltage. So the data given could be 160 to 280 or 140 to 320. So in this, what are the feature you need to extract? If it is between 140 to 230, pick the data. Or otherwise, if it is from 230 to 280, pick the data. Which data you need? That is called as data pre-processing or data cleaning. You will be given a raw data. In the raw data, which data you want to extract? That is called as feature extraction. And with that feature extraction, you need to select the common point and you need to select the data. So the data collection is a manual process, and the feature extraction can be done with the help of a particular algorithm. And after feature extraction, it has to be given to a model, and the model you will be defining it already based upon the system requirement. And after that model, the algorithm based upon the statistics or based upon the machine learning approach, it may predict whether the machine will fail, machine will run properly, or yes or no, or whatever it can be, faulty or non-faulty, etc. So this is the process. Any doubts so far?
No, sir. Participants, do you have any doubts, any queries?
No.
No.
So you
Okay.
can continue, sir.
Yeah. The artificial intelligence and predictive maintenance to predict fault in machine. In artificial intelligence, there are many models are available, many techniques are available. And with the help of artificial intelligence also, we can forecast certain faults, but it can just forecast, but it cannot predict. There are a lot of difference between this prediction and forecasting. Okay, I'll tell you the difference later. And this is the process: reactive, periodic, proactive, and predictive. These are all the maintenance process. And if you say in a smart grid, there are not a lot of data analytics required. And the data analytics is mainly used for generation as well as in the customer point. In the distribution and in the transmission, also there are certain part of data analytics required. I'll tell you where it is, where it can be implemented. In India, the data analytics started in the consumer side, that is in the prediction of a particular system with the help of advanced metering infrastructure that we call it as AMI. In India, the smart grid, the concept of smart grid starts with the AMI. Okay, I'll tell you what is AMI later. So how we can implement data analytics in smart grid? The first one, collecting, managing, cleaning, and storing data. Here, data is collected from variety of sources. Example, from grid sensor, advanced metering infrastructure, and in SCADA. SCADA, I think you know, SCADA is supervisory control and data acquisition system. So here I mean in the generation, in the transmission, in the utilization, there are different components involved in it. The component could be a relay. That component could be any of the switchgear component. From the relay or any of the switchgear component includes relay as well. From that switchgear component, if you acquire a data, and that acquired data is stored in a cloud or in a server, that can be done with the help of SCADA. Supervisory control. The control can be done with the help of a particular software. And data acquisition. Acquisition in the sense data can be acquired from the system and I have to store it in a cloud or in a server. Or otherwise, I can place some sensors randomly everywhere. Like I can place hall sensor, current sensor, voltage sensor, anything. I can place innumerous number of sensor and I can collect the data. Or otherwise, I can use AMI, advanced metering infrastructure. AMI is replacing the energy meter. Energy meter purpose is to calculate the number of units consumed. Apart from that, it may tell you the kilowatt, kVAR, frequency, voltage, current, power factor, etc. Apart from that, advanced metering infrastructure is the one which consists of the energy meter application as well as a SIM, a GPS. It will tell, if at all, if there is any fault occurs, it will tell with the current time stamping, with a geotag as well. So that is the purpose of AMI. So with this, we can collect the data. After collecting the data, you please compare what I am showing now and the previous block diagram. This one. Okay, I'm trying to include the smart grid concept in this predictive model by this particular block diagram, by this particular diagram. Second one, extracting and analyzing data. Once cleaned data can be used for analysis, various statistical algorithms can be applied to analyze the data. And third one, reporting. Data visualization techniques employed to clearly and efficiently communicate the results in the form of a dashboard. Okay, the dashboard could be an app, dashboard could be a graphical user interface, etc. And finally, analyzing big data thus enables the business user to make better and faster decisions. This system seems to be very simple, but I'll tell you where the blockchain, the smart grid concept will be implemented. As I told you, electricity is a commercial commodity like gold and chemical. It's the price of the commercial commodity keeps on varying. For example, for Tamil Nadu, per day requirement is 18,000 megawatt hour. 18,000 kilowatt hour, I think. I'm sorry, 18,000 kilowatt hour. And how these 18,000 kilowatt hour are being generated? Maybe it consists of three parts. One is the state government itself generating some of the electricity, and it can borrow from central government, and it can borrow from private party. So depending upon these three aspects, the price of the electricity, the price of the commodity can vary. And it keeps on varying depending upon the generation. It can vary depending upon the R bar P ratio. R bar P ratio means reserve by production ratio. A lot of factors involved in it. So those things, apart from that, we are introducing the concept of smart grid. Smart grid in the sense, some of the private player may generate electricity with the help of solar. Some of the private players can generate electricity with the help of a biogas, biomass, geothermal, wind energy conversion system, etc. All these are all variable quantity. From July to September, wind is predominant, and you may expect high electricity, high production. And rest of the time, you may get a dip. Similarly, during the entire 365 days, you may get high output from the sun in the place of Madurai, Theni, etc. But it may vary in other parts of the country or the state. So there are a lot of price variation. Depending upon these price variation, the per unit cost of the electricity may vary. So here, because of these price variation, you may need blockchain and other concepts for determining the pricing of an electricity or pricing of the commercial commodity. Because of that, I need data analytics and blockchain. So how we can implement data analytics in smart grid? Smart grid data analytics enables utilities to move to a more proactive analytics. And with historical and real-time data, it can predict and prescriptive analytics for building real value to mitigate potential problems before they arise. This is the purpose of data analytics in smart grid. So these things I can implement, I can explain with a use case. Fine. This is a very important slide. The smart grid data analytics can be done with the help of the following process. As I told you, these are all the different methods in which you can mine the data. Here I'm going to tell you with the use cases, what do you mean by smart meter? From the educational point of view, it is possible for us to develop a smart meter, and that can be used for analyzing the data. I'll tell you how. And that can be used for different things. For example, for asset optimization, distribution network planning, equipment management, network and device configuration and troubleshooting. Second, from grid optimization, it can be used for load forecasting, outage management, power quality data, conservation, voltage reduction. From customer operation, we can use it for theft detection, rate plan modeling, campaign management, customer segmentation, credit and collections. From the customer engagement, again, conservation tips and suggestions, rate plan selection. The first one, what I have shown is customer operation. Now I'm showing the customer engagement, efficiency program measurement and planning, prepay demand management. So these corresponding slide, each and every slide, every point is an individual PhD work. I'm telling you, you can select a topic of asset optimization. In that asset optimization, you can select your PhD topic as distribution network planning. How can I implement? I'll give one example. Distribution network planning. You can take one typical IEEE 13 bus system or IEEE 14 bus system. In that IEEE 13 or 14 bus system, you can implement with the help of a MATLAB or any other PSIM or ETAB or whatever it is. In that, you can collect data. From the data, you can give the data to the model developed using MATLAB again, or otherwise you can use any of the Python programming to develop a model. And finally, you can give an output that in the distribution network, when the fault will occur, that can be planned, that can be informed, that can be forecasted. So this is one of the application of data analytics in distribution network and planning. Similarly, in the asset optimization, we are optimizing that asset either in the equipment side, in the distribution side, or in the network side. Similarly, grid optimization, load forecasting, outage management. Simply, I have given it as outage. The outage could be because of voltage, Outage could be because of the 7 power quality indices, anything. Okay. So each and every topic is an individual PhD. So now, so far we have discussed about the importance of predictive analytics. Second, why we need to implement predictive analytics with the help of machine learning concept. Third, what are the different machine learning concepts available? And what are the different predictive model available? Next, what are the softwares available? And how to create a model, how to model the particular system, what are the procedures? And I touched upon the concept of smart grid. In the smart grid, what are the different topics available to implement the predictive analytics and what is its purpose? So far, I have discussed these points. Any doubts so far? Any clarifications required?
Participants, do you have any clarification? If you have any queries, you can raise now. So we shall move on, sir.
Okay. So the first case is we have developed a solar PV system like 5 kilowatt of solar PV and 5 kilowatt of thin film. This we can call it as a smart grid. This is a mini grid. We can call it as a mini grid. And this grid is connected to the conventional grid. And we have utilized this for our conventional applications. We have electrified a particular lab with the help of 10 kilowatt of solar PV. And how I have used the concept of data analytics here. We have integrated two systems here. One is 5 kilowatt of monocrystalline and 5 kilowatt of thin film. So these two systems are integrated because even though both are solar PV, both will work individually. Meaning is solar PV of monocrystalline will have different IV characteristics when compared to polycrystalline. But with a common inverter, we have integrated both the system, and through that inverter, it is being connected to the grid. So the complexity is A monocrystalline, B thin film. These two are integrated to a common DC to DC converter. I think you know the basics of solar PV, no need to explain further. These two have connected to a common DC to DC converter, and from the DC to DC converter, it is given to an inverter. Before connecting it to the common DC to DC converter, monocrystalline will be connected to a DC to DC converter. Thin film will be connected to a DC to DC converter, and both is connected to another DC to DC converter, and finally it will go to the inverter. And from the inverter, it is connected to the grid. Here we gave two options. One, if the grid is not available, the entire system will be system in the sense we have a specific load of 10 kilowatt, which is nothing but lighting load, motor load, fan load, etc. Without AC, we have given it to many of the loads. If there is no tangent load, if the power is not available, then the system will run with the help of solar PV. That is 5 kilowatt of monocrystalline and 5 kilowatt of thin film. If there is a supply, then my system will generate electricity, because if it is a daytime, it will generate electricity. The preference will be given to the solar PV only. If during the nighttime, if there is no power supply, then my system will run with the help of battery. If there is a power supply, then the system will run with the help of the tangent core. I think you can understand what I'm saying. So my system or my load will have two sources. One is solar, second one is battery, third one is EB from tangent core. I have developed a common converter that consists of an intelligent controller that intelligent controller will tell when to switch from solar PV to battery to the grid. Apart from that, the intelligent controller will take data points from solar PV, from the grid, as well as from the battery. And with the data points are collected minute by minute. Sorry. With the data are given to my algorithm. My algorithm will tell if at all if there is any dip in the performance of a particular panel. I have like around 50 panels approximately. If at all if there is any dip in the particular panel, my intelligent controller will identify and tell which panel has to be replaced. First point. Second point, the solar PV system has to be integrated to the grid with the help of my inverter, that we call it as a grid inverter. So if at all if there is any mismatch in the voltage between the grid and the solar PV, that has to be intimated by my inverter, and that has to be documented, or the data has to be collected and stored it in the cloud. So that is also being taken care by inverter. And when to switch from the power supply from EB to the grid, the battery, the time stamp also to be recorded. In that way, the maintenance factor of the battery can also be monitored with the help of the data collected by the intelligent controller. So this is how data analytics can be useful for this kind of a solar PV grid connected system. And these are all the system. This is a 5 kilowatt monocrystalline. This is 5 kilowatt thin film. Any doubts here? Any doubts?
Mani sir, kindly enable Mr. Mahendran. He has raised his hand.
Permission given, ma'am.
Mr. Mahendran, you can raise your doubts, sir. Mr. Mahendran? Sir, we shall move on, sir. Yes, he raised his hand, but he has not responded.
Okay. By mistake, he would have. One second.
Yes, sir.
Okay. So second case study is we have done a work on wind emulator. The purpose of wind emulator is we want to emulate a wind energy conversion system. Emulate in the sense we will not be having a simulating model. Apart from that, we will have a physical model of different wind energy conversion system. Like we have SEAG, SRIG, PMSG, PMDC. All these wind turbine generators are modeled, designed, modeled, and physically developed. And these wind turbine generators are connected to a DC shunt motor, and shunt motor is connected to a DC drive, and DC drive gets its input from a MATLAB. It's a very, very complex system. I'll tell you one by one. The MATLAB consists of a physical model, and model developed using a MATLAB, and it can be for simulating a particular place. If you tell a latitude and longitude, with the help of that latitude and longitude, the MATLAB model will simulate how will be the wind speed in that latitude and longitude. That is modeled using a MATLAB. I think you can understand. That is given as an input to the DC drive. So the MATLAB model drives a DC drive, gets its input from a DC drive, gets its input from the MATLAB. From the DC drive, the speed is adjusted to run a DC shunt motor. So the wind input is nothing but the DC shunt motor. From that DC shunt motor, it is given to the generator. So if I say Madurai, Tyagarajar College of Engineering has a latitude and longitude. In Madurai, throughout the year, what will be the wind speed is modeled using MATLAB, and that speed is given as an input to a drive. Drive in turn run the motor, meaning is the wind speed is completely simulated or emulated using this particular system. So what will be the output of my generator if I run my machine in Madurai? That can be emulated with the help of this particular model. So I no need to go to physically to a place. Sitting at Madurai, I can be able to tell the results of a particular place in India if I know only the latitude and longitude. The result in the sense, what will be the output of my PMDC, PMSG if I install a windmill with the help of this generator? Any doubts here?
Mahendran sir, mic is enabled, sir. Sir, actually,
Mahendran,
sir, actually, he's posted question in chat box, sir. Actually,
Okay.
Sir, how to identify if a solar grid is not working? Any methodology is there?
Solar?
How to identify if a solar grid is not working? Any methodology is there?
No, if there is no voltage, then it means that it's not working. Simple. There is no output. I'm sorry. If there is no output from the inverter, it means that it is not working. It may not work because of two things. One, there is no enough input from the sun, or there might be a fault in any of the panel, or any of the converter, or in any of the inverter of itself. These are all the options. Anything else?
Excuse me, sir.
Yes, please.
Can you give more light on this MATLAB interfacing for wind profile?
Yeah, I can. You might be knowing about DSpace.
Not
Hello?
details, a little bit.
Okay. The purpose of DSpace or any other hardware in loop system is you have different simulator. It can be MATLAB or any other software. If you want to implement that software in real-time application, you need an interface. Here, I have a DC drive. I want to give input to the DC drive through MATLAB. Meaning is, in my system, in my computer, I have my MATLAB. Physically, I have a drive. So to interface between MATLAB and a drive, I need an interface. That interface could be any of the hardware in-loop system or DSpace. DSpace acts as an interface between the simulation and the real-time application. So if I do some changes in the MATLAB simulation, that real-time, it can be implemented using DSpace. For example, assuming that you are forecasting some wind model, and that for the wind model, you have developed some model with the help of a MATLAB. So that model, if you want to do it in real time, you need an interface. That interfacing is nothing but a DSpace. Is that clear?
So DSpace is a paid intervention which we need to purchase, if I am correct.
Yeah. DSpace is quite costly. Otherwise, you can go for any other hardware in-loop model. There are low-cost hardware in-loop models are available in the market.
Sorry, sir, but if I understood correctly, when we were trying to create a wind emulator, we tried with a single-phase induction motor with VFD control.
Okay.
Instead of DC motor, what you are saying here.
Okay.
So does it mean that I need to control the reference of that VF variable frequency drive as per the wind speed of that particular location? Is that what we want?
Exactly. The pitch angle variation, everything you need to model using a MATLAB. See, what is
Okay.
VFD basically? VFD will vary the speed based upon the frequency, 0 to 50 hertz frequency. Here, what I meant drive is nothing but a VFD. Okay. It's a variable frequency drive. It is nothing but a VFD. Instead of giving it to an induction motor, I have given it to a DC shunt motor. DC motor will run with the help of a drive. Instead of varying the frequency with the help of, since we DC drive, we don't have to change the frequency. I'm varying the speed with the help of a MATLAB. How will I vary the speed? I vary the pitch angle, or simply the speed, or simply the wind speed. Do you understand?
Yes, yes, sir. Understood. Thank you.
Okay. Any other doubts? Any other doubts? Okay. So it's not the end of the story. Apart from that, what I have done is like, now the generator, I have used different generator. Here I have given a trolley kind of a model. So here I have connected to SRIG. If I want to check the performance of my generator for the same input, I move this trolley, I can connect it to SIG or PMSG and PMDC, and I can check the output or check the performance. At the end of the result, I could say which generator will give a apt or exact output, or required output, not exact, or required output for the corresponding input for the particular location. This I can able to tell to the customer. Apart from that, I have connected this system to the grid. I think you can see the block diagram here. I have connected the system to an alternator, wherein which the alternator acts as a grid. Before connecting it to the alternator, I thought of connecting it to a hybrid system. That hybrid system is wind and solar converter. Here I have connected a 2 kilowatt solar PV system. Again, thin film and monocrystalline. This is also one of the hybrid. And this converter gets the input from solar PV as well as from the wind. Here I have a DC-DC converter, because here the output is AC, that will be converted to DC. From DC, it has to go to the inverter through a DC-DC converter. Here DC to AC converter, it is a multi-input inverter. One input from solar, another input from wind. That is connected to an alternator, and alternator again runs with the help of a DC motor. So here I can initiate a fault, and I can check the performance of solar, I can check the performance of the wind. So this entire setup is nothing but a wind emulator, and all the data I have collected from each and every checkpoints, from the drive, from the motor, from the generator, from the inverter, from the solar, from the alternator, and I have stored it in a system with the help of a DAC. This DAC is from National Instruments, Data Acquisition Interface. And this is quite 2 lakh. This DAC alone cost around 2 lakh. And this DAC can give the input directly to the MATLAB, or it can directly give the inputs to a server. Okay. So this is the complete wind emulator. Any doubts here? Any doubts?
Participants, do you have any doubts? Any queries? You can continue, sir.
Okay. Okay. And the next is case 3. And here what we have done is like we have developed a small wind turbine generator. And this is not a practically possible model, but even then we have developed a small model as a prototype. We call them as a pico turbine, and nothing is related to smart. I mean, it is one of the nano grid or a smart grid, but nothing related to what you call data analytics. Here, what we done is we have done a lot of survey for forecasting. We have done a data analytics. we have done a lot of survey and defined that and did some manual calculation using formulas, and we have finalized that 600 watt of model of turbine is enough for developing this. I think I have the model. Yeah, we have developed an airfoil. It's something like, I have the picture. Tell you. I'll show it to you. We have developed a PMDC generator using Maxwell, ANSYS Maxwell. Yeah. So we have developed an array structure wind turbine model. We have taken the inspiration from solar PV panel. So instead of each and every cell, we have converted that into a small wind turbine model. And to develop this small wind turbine model, we have done this ANSYS simulation. We have calculated what should be the optimal wattage. This optimal voltage is 600 watt. Each and every wind turbine model is 600 watt. So each and every model consists of 3-blade system. So even at 1.5 meters per second of wind speed, my wind array structure could able to generate some electricity, useful electricity. I think you people can understand what I'm trying to convey. So normally wind cut-in speed required is 7.5 meters per second. But our array structure requires simple 1.5 to 2 meters per second. You no need to install wind turbine in any of the pass. You can install it anywhere in India and you can get the output. So this is the objective. So that's it. And now case 4. Case 4, we have done it a flexible solar tent application. And this flexible solar tent is again a smart grid. The capacity is just 1 kilowatt. And the purpose is mainly for defense application and mainly use it for makeshift application. Like we have framed flexible solar array like this, and it can be buckled. And finally, you can get a flexible solar tent like this. So each and every panel is fixed in a tarpaulin, and it can be used it for makeshift application. Assuming that you are going for a picnic, you can use this. You can use it as a bag. It's a very big model used for solar tent. You can also use it for charging your laptop, in the case of a solar bag. And next very important concept. With this concept, I will wind up. We call it as a smart energy IoT meter. This meter, apart from checking the electrical parameter, we have developed this meter to check all the physical parameter like temperature, speed, vibration, noise. Almost 15 parameters it can measure. The electrical parameters like voltage, current, power factor, real power, reactive power, apparent power, power factor, unit consumed, maximum demand. In the case of any of the process industry, if you want any physical parameter to be measured, that can also be measured. That can also be sensed, and it can be monitored with the help of IoT meter. We have developed 7 variant 1A, 1B, 1C, 1D. And in 1D, we have 3 model 1, model 2, model 3. And it is mainly used for manufacturing industries as well as for distribution network. Manufacturing industry, any machine you can fix this meter, and this meter will give the data to a server. And in the server side, we have a unique software, and the software will be able to predict and give reports in form of SMS in the app, in the graphical user interface. In all the ERP, we can use this. And also this meter can be used for distribution network, and this meter can be fixed in any of the transformer, any of the distribution line, and all the data can be collected. It can be used for demand side management. So this is the first variant. It is being tested at textile mill. Apart from measuring all the data, it can also be used for measuring the harmonic. Normally, high-end Fluke power analyzer or Yogago power analyzer or any of the power analyzer is being used for measuring the harmonics, but that can be replaced by our energy meter. And the cost of this energy meter is very, very cheap when compared to this power analyzer. And we have tested and we have compared the results as well. And it is tested at different textile mill. This is smart meter variant 1B. And these meters will check the data, measure the data and transmit the data to a software. In the software, you can do all the communication, all the reporting part. See here, it's a very simple meter. It can measure the total harmonic distortion with plus or minus 1% accuracy. So these are all different meters. And this is the corresponding energy management system software. Case 6, we have a smart grid lab. I think I can skip this because many of the colleges have already have this kind of a smart grid lab. So with this, I will conclude now. If you have any doubt, again, these models I have already discussed, so I'm skipping it. So in conclusion, machine learning enables organization to harvest a higher volume of insights from both structured and unstructured data. What you have to do is you have to collect the data, give the data to a model. From that model, it can be given for a particular application. So with this, I'm concluding. Before I conclude, I would like to share some of my books. These books, you can use it for your research. I'll quickly run through it. Solar PV. And this is Electronics in Textiles and Clothing, published in CRC Press. This is completely using MATLAB. In all these books, all the MATLAB blogs, M code, everything is given in the appendix. This is Power Electronics with MATLAB. It's published in Cambridge University Press. This is in textile machines. This book is dedicated only for power quality. This book will teach you how to write a deep learning program using Python. This is Power Electronic Converter for solar photovoltaic system, published in LCWork. This is software tools for the simulation of electrical system. This is again soft computing techniques in FACS. This is related to electric vehicle. All these corresponding books is related to decision making. This is in predictive analytics. This is in machine learning. This is for NLP. This book is specifically talk about the importance of EMI and EMC. That's it from my side. If you need any doubts, this book is specifically for blockchain. Okay. And this is my latest book, Predictive Analytics using MATLAB for Biomedical Applications. And this is on fundamentals of machine learning. That's it from my side.
Auntie கூப்பிடுறாங்க நீ ஸ்கூல்ல ஆன்ட்டி
இது யாருடைய மொபைல்?
Any questions?
The session is open is for it is now you can raise any questions. Have any queries, you can get it clarified. Participants, if you have any questions, you can get it clarified now.
Hello, sir.
Yeah.
This is Dr. Ishan Samanto from West Bengal.
Okay.
Sir, I do have one question that as I do work on electrical fault system, that means my research is on basically I work with fuzzy. So my question is that initially, if we do apply machine learning in case of fault analysis, suppose overcurrent fault or differential in case of overcurrent protection, differential protection in case of protection, power system protection. Then, sir, is it very the output that will be getting, or the predictive analysis that will be getting by implementing machine learning? And if in case of machine learning we are using fuzzy, suppose we are considering some data, this electrical fault analysis data is not very consistent, it is very much varying. So in that case, I would like to know that how much it will be benefited if we go for a machine learning application in case of overcurrent protection or any kind of protection, transformer protection or something like this. So that is my basically I am very much confused in these cases, because I have seen that in case of applying machine learning, what the results we are getting, it is good, but I am it's very doubtful that whether it will be feasible or not. So in that case, I do have very queries. So that please clarify this thing.
Yeah, I can understand. But how many data you have given?
Sir, my data is around 2,500.
No, it is not sufficient, sir.
So if I go for more than 5 to 10,000, around 10,000, then it would be sufficient. But my question is that, sir, I might be getting a result, but is it feasible in case of real world system if you are applying?
Yeah,
so how is it possible?
No, it is very much possible. It is very much, because already people are using it.
Yes, sir, I've seen.
இந்த ஒழுங்கு சேர்த்து வர அந்த ரோடு வந்துடும் அப்படிதானே இந்த இது இருக்குல்ல சரி.
It is very much possible, sir, because in most of the system people believe in data. Okay, and your algorithm should be reliable first of all.
Okay.
The feasibility means whether your question is like whether can we rely on the output? Is that the question?
Yes, sir. Because this fault, and I'm just giving one example. In one of my senior who is working in South Africa, so he was actually coming. We are while doing my PhD, we had a conversation that some fault is actually coming, which fault is actually not. That's very uncertain. It has no dimensions, and people are very much confused. So in that cases, I think the machine learning will be dealing with the data that we are providing, and might be it is possible some uncertain scenario is happening which is not possible for machine learning to segregate from the learning data what it is what we are incorporating into it. So in that case, my question is that if you are implementing machine learning, the system will be becoming more costly in real world system if you are implementing it. So in that case, that's why my question is that if you go for an ANFIS, might be we are hybriding, that fuzzy learning will be there, but the machine learning predictive might be there. So can we go for some hybrid technology, or only this machine learning algorithms are good enough to solve the problems in case of real world system where the prediction is very much complex?
No, my opinion is machine learning itself is enough.
Yes, sir. But we have to provide more data, more than 10,000.
Now, what you give, what you get.
Yes, sir. Yes, sir.
If you get real time, if you give authentic data, your results will be authentic.
Okay.
You should not blame on the algorithm, right?
Yes, sir. Yes, sir. And sir, my last question is that which predictive algorithm is best for this power system for production, if you kindly suggest?
Which algorithm? That depends on a lot of SVM.
நடந்து வர ஏரியா தானே, ஏற்கனவே இதெல்லாம் நடந்து வர ஏரியாவா?
Hello.
Yes, sir. Yes, sir. Please.
My suggestion is SVM is better. Hello. Hello.
Yes, sir. Sir, thank you. Thank you.
Okay. Thank you. Any other questions? If not, we can wind up.
Participants, any question?
Sir, one last question I do have again. Sir, in case of solar panel, in case of solar grid, I got an information. Actually, I would like to know that the PV cells, whatever the grid of the PV cells or the array of the PV cells, if some of the PV cells getting some fault might be coming in the center of the grid or in the center of the array, one of the because of that faulty PV cell, so the entire grid is actually the efficiency of grid is actually dropping down. So what could be the possible solutions you can go for it to predict that? So is it possible to I would like to know that how to I mean isolate that faulty part from the entire grid so that the grid could be saved in case of solar grid. Actually, I'm asking this question.
There are three parameters required. One is the voltage. Second one is the temperature. The third one is the current. These three parameters is enough to identify the faulty panel.
Okay, sir. Okay, thank you, sir.
Okay. Hello.
Participants, any other questions? Okay, sir. Thank you so much, sir, on behalf of SLS College of Engineering and ACT. I thank you. I'm sincerely thank you for giving the better analytics.
Thank you, ma'am.
Indeed, it was a benefit for everyone. Thank you so much. Right amidst your busy scheduling, to share the knowledge with us. Thank you so much, sir.
Thank you, ma'am. Thank you
Any
all.
other question? If you have any, thank you. Thank you.
Madam, one more question, madam.
Hello.
Hello. Sir? Sir, is it audible, sir?
Sir, Nandakumar, sir. Nandakumar,
Yes.
Speaker has left the session. He has left the session. No issue. You can you can write the questions to us. We'll forward to him, right? And we can expect the answer also from him.
Okay, madam. I have one clarification, madam. That's why I asked you.
Okay, sir. Okay. Thank you so much. Thank you. Participants, you can take a break for 10 minutes. Kindly join at 7:40. You can have the so at 7:40 we will commence our second session. Thank you.